Welcome back. My name is Stephanie Austin, and in this session we'll discuss identifying adaptation options. Adaptation for water-related infrastructure investments and other water management contexts can include a really wide range of activities. Adaptation activities or measures in this context can target, for example, the infrastructure project or investment itself. It can target the context that it sits in, for example, national infrastructure policy, or it can target supporting climate services available. Adaptation activities can also be very specific, for example, focusing on how spillway channels or dam reservoirs can be adapted to climate risks. Another adaptation option could be simply to do nothing if that's what the most cost-effective approach is. The goal during this step of the adaptation process is to brainstorm a long list of possible adaptation options to address the climate risks that you identified during the previous climate risk assessment step. Adaptation measures can target different aspects of climate risk. You could choose adaptation options that reduce the hazard associated with climate risk, or ones that minimize exposure, adaptation options that minimize vulnerability, or more broader cross-cutting issues. So for example, adaptation measures that create an enabling environment through enhancing finance availability or create an enabling environment through strong policy. Many adaptation measures can also provide multiple benefits, or what's also known as co-benefits. For example, if an adaptation measure is to plant trees for slope stabilization, co-benefits could be diversity conservation if the tree species is really carefully selected. And also another co-benefit could be climate change mitigation, since trees act as carbon sinks. Taken together, some adaptation options can be complementary, but others mutually exclusive. So for example, two complementary adaptation measures could be investing in early warning systems to become more people-centered, and also increasing the height of the dam crest to allow for a larger freeboard. So in other words, to increase the difference in elevation between the dam crest and the normal reservoir water level. So implementing these two measures are complementary and they're not mutually exclusive. On the other hand, an example of a mutually exclusive adaptation options that could not both be implemented could be, on the one hand, increasing physical protection of an existing infrastructure project, and on the other hand, choosing to relocate the infrastructure. You can't both relocate the infrastructure and physically protect the infrastructure that you're leaving behind. Another aspect that's important to consider when you're identifying adaptation options is including a wide range of stakeholders and a multidisciplinary team, since they can be really valuable in identifying a diversity of possible adaptation options. Let's go through some examples of adaptation options to give a bit of a snapshot of what adaptation can mean in the context of hydropower infrastructure. So let's say that our component of interest is the dam reservoir, and the climate variable is changes in precipitation and stream flow. Now, changes in precipitation and stream flow could lead to reservoir slope instability, causing landslides and trees falling to the reservoir. Now, what kind of adaptation measures do you think could be implemented to reduce the climate risk associated with this reservoir slope instability? Why don't you pause the video and think about it for a moment? A couple examples of adaptation options here are one to reduce exposure by doing a detailed reservoir rim stability assessment, leading to slope stabilization in risk areas. This could be done through reforestation or afforestation, which is a great example of ecosystem-based adaptation, which we talked about in Module 2. Another example also to reduce the hazard could be to stabilize slopes through green-gray embankments, which is another great example of ecosystem-based adaptation. Another potential climate impact from changes in precipitation and stream flow could be a change of river regime with reduced base flows and increased floods. So can you think of any adaptation measures that might fit here? You can pause the video for a moment. One example could be to try to reduce vulnerability and increase protection by increasing spillway capacity to allow increased flow. Another option could be to try to actually reduce the exposure altogether. So this could be done through floodplain widening, which is another great example of ecosystem-based adaptation. Lastly, another climate impact that could happen as a result of changes in precipitation and stream flow could be increased or decreased sediment loads impacting operating regimes of the reservoir. So take a moment to think about what kind of adaptation measures might reduce the climate risk here. You can pause the video. One option could be to try to reduce your hazards by riparian planting along the river. In other words, planting trees along the river, which is another example of ecosystem-based adaptation. Another option could be to try to reduce vulnerability and increase protection through additional dredging. And another option could be to reduce vulnerability and increase business continuity by changing operation methodology. On the last slide, we highlighted a few adaptation options that are good examples of ecosystem-based adaptation, and we also discussed this during Module 2. But just as a recap, we've put on the slide a large range of ecosystem-based adaptation measures that can be used related to hydropower infrastructure. So I encourage you to take a look again at these, and if you'd like to review, you can always go back to Module 2 to learn more about ecosystem-based adaptation. Thank you very much for your time and attention, and I look forward to seeing you in the next session.